Find the unit tangent vector. This is really unit tangent vector for RT, t e to t e to negative 2t. Okay. So if you have RT as t e to t e to negative 2t, that gives you the velocity vector, which is a derivative, as 1 e to t, and then you have to use the chain rule to differentiate this, so it's going to be negative 2 e to negative 2t, right? And then the unit tangent vector is basically the same vector as vt, but you resize this so it becomes a unit vector. In other words, you have to normalize the velocity vector. That's what the unit tangent vector is. Okay, so that's going to be 1 e to the t, negative 2 e to the negative 2t, divided by square root of 1 squared plus e to the t squared plus negative 2 e to the negative 2t squared. Okay, so that's what it is, except that it's asking for t of 0. Usually you can simplify this, but usually what you have down here is not something you can easily simplify, so you end up just getting stuck with some really complicated one. But if you're given a value, you can actually evaluate it. T of 0 would be, that means you're replacing 0 for all the t values, so you're going to be getting 1, e to the 0 is 1, and minus 2 times e to the 0 is also negative 2, and then square root 1 squared, this is 1 squared, and this is negative 2 squared. So what's that? 1, 1, negative 2 over 1 plus 1 plus 4. So it's going to be 1, 1, negative 2 divided by square root of 6. Now this could be good enough, but sometimes they might ask you for each individual component, so in that case you have to divide. See, this is a scalar multiple by 1 over radical 6, so in that case scalar multiple to a vector is you get to apply this to each individual component, so the answer is 1 over radical 6, 1 over radical 6, and negative 2 over radical 6. Yeah, and on the web work, you may have to calculate these and plug in something like 6 decimal places or something it should accept.